Hey guys, welcome back to Algebra 2 Trig. Today we're going to look at lesson number 23. And so yesterday we started looking at angles in a coordinate plane. Today we're going to move on and we're going to continue doing that. We're going to talk about these angles in a coordinate plane, but now we're going to talk about them in terms of radians. So this is just another way to look at an angle. Up until this point, we've always looked at angles as degrees. And so we're going to do the same thing just in this different term. So remember, when we're talking about angles on a coordinate plane in standard position, okay, so let's just say this is my angle that I have here. Okay, so remember, it says reference angle is drawn from the terminal side to the x-axis. So remember, when we're talking about reference angles, it's always from this stopping point, this terminal side, to my x-axis right here. So if this is my angle, this is my reference angle right here. Okay, so remember that today when we're talking about radians. So what is a radian? So we've talked about it in your calculator, how make sure your calculator is always in degree mode. This is the reason. There's two different ways to measure angles, actually three. For us, we're just talking about two of them, but degrees and radians. And so up until this point, we've always looked at an angle like this in degrees. And so what that means is if you have somebody standing at the vertex here and looking out at the angle, what does it look like? That's what a degree is. A degree can be measured with a protractor. Okay, so how open the angle is. When we talk about radians, okay, it's a completely different way to think about what a angle is. And so it says here, it is a way to measure an angle by the length of its arc. So in theory, you can measure the angle with the tape measures because it's a distance. And so if I look at this same angle over here, when I'm talking about this angle in degrees, it is literally the distance. If I started at this point here and walked to this point here, this distance right here that I would walk, that is this angle in radians. Okay, and so a degree is how open it is, how far open it is, measured with a protractor, measured in degrees. Radians is literally a distance. So it's how far it takes to get from one point here, walking along this arc, to get to this point here. Okay, and so that's the difference when we're talking about radians and degrees. Again, they both measure an angle. Okay, just like centimeters and inches can both measure a distance. They both measure an angle, just two different ways to measure it. So let's talk about algebraically how to kind of go between degrees and radians and what radians looks like whenever we're going around a circle. So first of all, we know that when we're talking about degrees, a full circle is 360 degrees. Okay, when we're talking about radians, we're talking about this outside arc here. So starting here and going all the way around the outside of the circle. Okay, so it's 360 degrees if we talk about in degrees. In radians, going all the way around the outside of the circle is just the circumference. Okay, well, we know the circumference of a circle is 2 times pi times radius. So 2 times pi times radius is going to give me this distance around the outside of the circle, which is radians. Okay, and so if I'm talking about the entire circle, it's whatever 2 times pi times r is. Now, for us with radians, we always think about it in terms of a unit circle. Okay, so for us right now, when we're talking about radians, we're talking about a unit circle. What we mean by a unit circle is that the radius is 1 unit. Okay, so for us, these radians could change if the radius was changing. But when we're talking about this, if you hear anybody ever talk about a unit circle, what they mean is that the radius of the circle is 1. Well, if the radius of my circle is 1, that means that 2 pi r just turns into 2 times pi times 1, which is just 2 pi. Okay, and so what that means is if I go all the way around the circle in degrees, it's 360 degrees. If I go all the way around the circle in radians, it's 2 pi. Okay, again, that's a length. That's if I were to walk all the way around the outside of this circle here, it would be 2 pi units long. Okay, and so that's a length. And so just like 360 is a full circle, 2 pi is a full circle in radians. So that's very important as we start talking about how to measure and how to draw angles in radians. So if I look at this, if I look at a full circle, we're going to talk about kind of how to break this circle down, just like we did with degrees. Okay, and so yesterday in lesson 22, we talked about how to draw these angles in degrees, and we talked about how this first quadrant goes from 0 to 90 if we're positive, and then we go from 90 to 180, and 180 to 270, and 270 to 360, and then we can just continue going around our circle. But we break this 360 up into kind of these 4 parts here. Well, we're going to do the exact same thing with radians. And so if I look at this here, okay, here's my starting point at 0 radians. If I go all the way around the full circle, we know that that's 2 pi, because 2 pi is a full circle. Well, then the way we want to start looking at this then is if the full circle is 2 pi, if I just go halfway around this full circle, that's going to be just pi. And so where we said it was 180 degrees in degrees, it's pi in radians, because a full circle is 2 pi, half a circle is just pi. And then we can break that up into fourths. So if half of this circle, this hemisphere up here, is pi, if I break that in half, that means this here has to be pi over 2. Okay, and so again, remember pi over 2 is the same thing as 1/2 pi. Okay, so if it's easier for you to think about it in terms of how much of the pi is it, 1/2 pi. This here is 1 pi. This is 2 pi. Okay, so if I have 1/2 pi, 1 pi, this is going to be 3 pi over 2, or 3/2 pi down here, because each quadrant is 1/2 pi. Okay, so I have 1/2 pi, 2/2 pi, 3/2 pi, and then over here I get 4/2 pi. Okay, if you ever need to change these into decimals, you can do that too to help you. Okay, so this is 0.5 pi, this is 1 pi, this is 1.5 pi, and then 2 pi. Okay, and so when we're drawing our angles, it's figuring out which quadrant they end up in. Just like here, we said, okay, 150 is past 90, but not quite 180, so we know it ends up in the second quadrant. We're going to do the exact same thing here. Okay, and so we're going to find out which quadrant does it end up in. Is it more than pi over 2 and less than pi? Then it ends up here. All right, and remember, if we go the opposite direction, if we're going negative, if we're going clockwise, it ends up the same way. This is just going to be negative pi over 2. This is going to be negative pi. This is going to be negative 3 pi over 2, and so on. Okay, so let's go ahead and look at drawing some of these angles. So first one I have here is 4 pi over 3. Again, remember, if you need to, if it helps you, it doesn't hurt to change this into 1.33 pi. Okay, that's what that is. 4 over 3, 4/3 is 1.33 pi. It's the same thing. And so when I think about this, first of all, it's positive. So I know that I'm rotating counterclockwise. Okay, so I'm rotating this direction. So remember, this over here is half. So this is my 0 or 2 pi. So this is pi. This is half of pi, or pi over 2. And so we're figuring out how far we're going. Well, if my rotation to get to here is pi, and here I have 4 over 3, I know I'm going a little bit further than that. We said down here it's 3 pi over 2, which is 1.5 pi. Well, if I'm looking at 4/3 pi, 1.33 pi, it's more than 1, but less than my 1.5. And so my angle, so remember, in standard position, our initial side's here, it's going to be more than my pi, but it's going to be less than my 1.5. And so my rotation here is going to start here and rotate to here. Okay, so now to reference back, terminals are reference angle. Okay, so now we want to find the reference angle. It goes from terminal side to x-axis. So this here is going to be my reference angle. Well, how far past pi, or 1 pi, did I go? Well, 3 over 3 would be 1 pi, so I went 1/3 pi past this here. So my reference angle here is pi over 3. Over here, same type of thing, we're just going negative. Okay, so this is my negative pi. This is half of that, so negative pi over 2. This would be my negative 3 pi over 2. This would be my 0 or negative 2 pi. So initial side. Now we're going negative 3/4. Well, we should know 3/4 is more than 1/2 and less than 1. So it's going to fall here in my third quadrant, which is more than 1/2 and less than 1. Now, you also should be able to recognize here, this is 0.75 pi. Well, 0.75 pi is going to be halfway between these two. And so when I put this in here, yes, it's in the third quadrant, but I can actually be a little bit more specific, and it's halfway between there. So my angle is this negative, so clockwise to here. And then again, we want to find the reference angle. So the reference angle is the terminal side x-axis, so it's going to be this here. And so how much further, if I have 3/4, do I have to go to get to 1? Well, that would be pi over 4. Okay, so this here is going to be pi over 4 because that's how much further I have to go. Remember, reference angle is always acute. Okay, it's always acute, so it's always going to be less than pi over 2, and it's always positive. Okay, well, we never have a negative reference angle. All right, let's look at these two. Standard position. So my initial side here is on the positive x-axis. 7 pi over 12. So I know here we're going counterclockwise. Here's my 1 pi. Here's my pi over 2. So 7/12. We know 6/12 is a half. So it's going to be a little bit more than a half. It's not 1, but it's a little more than 1/2. So it's going to be somewhere right here. We're going counterclockwise. So here's my reference angle. Well, when we're saying here is we're saying, well, if I'm at 7/12, how much further do I have to go to get to 1? So that should be 5 pi over 12. Over here, we're going negative. So here's my negative 1/2. Here's my negative pi, so negative 1. 9/8 is a little bit more than negative 1. So when I'm rotating, I'm going to go a little bit past my negative pi here. So my rotation is going to be this direction here. Okay, so then our reference angle is just this little part here. So I'm saying how much further past 1 did I go? Well, that would be 1/8 because 8/8 is 1. So I go 1/8 past it to get to my terminal side. All right, let's do these last two. So here's my initial side every time. Standard position, positive x-axis. Negative, so I know negative 5/3. I'm rotating clockwise. So here's my negative pi over 2. Here's my negative pi. Here's my negative 3 pi over 2. So that's negative 1/2. And then here's my negative 2 pi. Again, if it helps you to think about this, this is 5/3 is negative 1.67. Well, this is negative 1.5. So I know it goes a little bit further past this here. So I know it's going to not quite be 2, but it is going to be past 3/2. Reference angle is here. So again, we're saying how much further past this 5/3 do I need to go to get to 2? Well, 2 is 6 pi over 3. So how much further do I need to go to get to 6 pi over 3? That should be pi over 3. Again, reference angles, always positive, always less than 90. It's always acute, so always less than pi over 2. Last one, negative pi over 12. Well, I know this is negative pi over 2, so I know 1/12 is less than 1/2, and so it's really just going to be this small angle right here, creating my reference angle right here. Well, if I have that reference angle, if we're going negative and I have this, my terminal side in the fourth quadrant, my reference angle is just going to be the same thing, but positive of what my original angle was. All right, I want you guys to pause your video, do these 2 examples. Once you're done, unpause your video, and I'll have your answers there for you. All right, here's your 2 answers you should have got. Over here, 10 pi over 9 takes us past 1 pi, and it just takes us pi over 9 past it. So that's my reference angle. Here's negative, so we're going clockwise. 7 pi over 4. Again, if it helps you to think about that as 1.75, because 1 3/4, you can. And so it takes me past 1.5, but not quite to 2. And so we have this angle here, and then my reference angle is this blue part here. We're saying how much further do I have to go to get to 2, which would be pi over 4. All right, go ahead and do your lesson number 23 practice.